All right, welcome back. I hope you had a wonderful, wonderful, wonderful break. Hope you enjoyed, relaxed, got away, just thought, well, didn't go far away, right? You stayed at home, kind of stayed away from people, right? But we're going to start back up. We are going to start with chapter 5. We are going to get chapter 5 done before we go on break at the end of the quarter, so we need to finish it up. We got 3 weeks to get this done, so we are jumping in with 511. All right, and you need paper, calculator, Chromebook, and warm-up. We're going to do a warm-up today just because I do need you to try to get your brain back into focus here. And then we're going to do problem 5.1 and 5.2 together here in class, or on the video today. And we're going to finish this lesson tomorrow. Now, if you notice, there is no review preview today because the homework, I'm taking a one-day lesson and extending it to 2 days, okay? So no review preview, just finishing up problem 5.2, okay? All right, here we go. Here's your warm-up. Make a sketch and label as many families of functions as you can, all right? I don't know what I just did there, but oh well. So that's your test right now. So please go ahead and pause the video and label as many families of functions as you can. Got it? Go. All right, so hopefully, let's see how many you came up with. First of all, there's this one, and this one is called linear. You can also, I mean, we could also go like this and say this one's also what? Proportional. And again, whichever ones you get wrong, add in a red pen. There is, there's, how about this one? And this one is quadratic. Quadratic. Okay? Then there is, I don't know, we're just going to go with several of them. So, there's this one here. What's that one there? Oh, and I should have the arrows there. That one is square root. Square root. Okay? Then there is this one. Let's go with this one. And then, actually, I got that backwards, don't I? Okay. So it should be like this. Sorry. Man, it's hard to do on the board. Okay. Looks like that. And then kind of like this, right? And this one is what? This one's called inverse variation. Variation. Then there's this one here. This one is exponential. Let me see. I know this one. This next one. Okay. This one is what? Absolute value. Absolute value. And then the last one that we've got that we've covered so far was this one right here, like that. Okay. And this one is cubic. I'm sorry, cubed root. I'm sorry. Cubed root. I'm sorry, man. I'm on a roll. Go figure. Goes like that. Cubic is what I showed you over there, but we didn't talk about that one. We did this one. Cubed root. Cubed root. There we go. There are the 8 families of functions that we learned, that we talked about. Please make sure you keep these in mind, okay? We are now going to start focusing on one of these. This chapter 5, is going to focus on one of these and kind of get you comfortable with that one function to where you know all the parts of it and you know exactly what they mean and what they're referring to. That's what we're going to go focus on right now. So let's get started here. How does a pattern grow today? Representing, look at that, exponential growth. And you know what the graph is going to look like because you just did it. Okay. So far in this course, you have been investigating the family of linear functions using multiple representations, especially tables, graphs, and equations. In this chapter, you will learn how a new family of functions learn about a new family of functions and the type of growth it models. So we're going to get comfortable with all 4 of these steps for exponential. Okay, cool. So let's get going. 5.1, multiplying like bunnies. In the book of Mice and Men by John Steinbeck, 2 good friends named Lenny and George dream of raising rabbits and living off the land. What if their dream came true? Suppose Lenny and George started with 2 rabbits and that each month following those 2 rabbits had 2 babies. Also suppose that every month thereafter, each pair of rabbits has 2 babies. Now here's what I want you to focus on, okay? Yes, rabbits are known for being able to reproduce rather quickly,
Okay, so that's kind of what they're famous for. They're joking. That's the running joke. And so look at those details. Let me read it again. Suppose Lenny and George started with 2 rabbits, and then each month following those 2 rabbits, or those rabbits had 2 babies. Also suppose that every month thereafter, each pair of rabbits had 2 babies. Yes, I know we're assuming that every pair of rabbits is automatically going to have a male and a female, and that they're going to be able to reproduce, which is not, of course, always the case. But we're just talking hypothetically here. We're just making an assumption here, okay? With your team, actually on your own, determine how many rabbits Lenny and George would have after 1 year, 12 months. Represent the situation with a written description of the pattern of growth, a diagram, and a table. What patterns can you find and how do they compare to the other patterns that you have investigated previously? Okay? And here's some things to keep in mind. What strategies could help us track the total number of rabbits? What patterns can we see in the growth of the rabbit population? And how can we predict the total number of rabbits after many months have passed? And so I want you to be thinking about that. What patterns, what strategies, how can we get this? This is tougher than you think. How can we predict the total number of rabbits after any number of months? And so that's the problem we're doing. Now, problem 5.1 is the problem, but problem 5.2 is kind of a further guidance on it, okay? So this is going to walk you step by step through what you're going to do, okay? So problem 5.2, how can you determine the number of rabbits that will exist at the end of 1 year? Consider this as you answer the questions below. First, you're going to draw a diagram to represent how the total number of rabbits is growing each month. How many rabbits will Lenny and George have after 3 months? Now that right there, this problem in itself should take you 5-10 minutes right now. So you're going to pause this video. You're going to try illustrating it, okay? Now, I'm going to give you some clues because some of you might be stuck. I want you to try. I want you to try for a couple minutes. If you think you're catching on and you think you're good, you can keep working. If you're stuck, unpause it and I'll give you some hints, okay? And then we will, when you're done, unpause it, we'll go over it, and then we'll move on to the next part. So I know it's a little tricky, but we're gonna do a lot of stop and go as we're doing this lesson, pausing the video, listening, and then continuing. Got it? All right, so right now you're gonna draw a diagram to represent just the first 3 months of how the rabbits are reproducing. If you got a pair, and they have a pair, and every month, every pair has a pair of bunnies. Got it? Go. Okay, so hopefully by now you have an opinion, or maybe you are stuck and you just want to see what to start off with. So I'm going to give you an example of how to maybe start off with. So here are my bunny. Oh, actually, here are my bunnies. Okay, I've got 2 bunnies, and the first month. Oh well, actually, here's the first question. Is this month 0 or month 1? Technically, this should be month 0, right? But then at the end in this month, they have 2 bunnies, okay? So now we have 4 bunnies. Now every month, these top bunnies are gonna continue to have a pair of bunnies. But now we got a second pair of bunnies that are gonna have bunnies as well. So now, each of these would have bunnies, right? But this would also have bunnies. So you might do your illustration that way. Maybe you choose to do it that way. Well, how do you differentiate which ones are the original? So maybe you say, oh, well, we'll mark those as the original one. And this is after 1 month, it's gonna be these. And then after 2 months, we're gonna add these, okay? Well, then after 3, okay, so 0, 1, 2, oh, we just need 1 more month, don't we? Okay, but the key thing is that every month, every pair has 2 bunnies. Got it? So please go ahead and try month 3, okay? And we'll go from there. Unpause when you got it. All right, so your month 3 should have then kind of looked what we had here. You have, oh, I don't want those to go away. Hold on. Oh, maybe you put these 2 over here, and these 2 over here, and these 2 over here, and then these 2 over here, right? Oh, come on. There you go. And now let's mark them somehow or another. How can we mark that they're the next month? So maybe we mark them in black, okay? Okay, So there we go. We've got the first 3 months, okay? We got the first 3 months illustrated. Was your illustration somewhat similar to this, or was it a little different, okay? The challenge becomes what happens if you go to 4 months, 5 months, and 6 months. It gets pretty intense here, guys. So let's look at letter B. As a number of rabbits becomes larger, a diagram becomes too cumbersome. Cumbersome means extreme, like really heavy, really burdensome, like just really, really too obnoxious to try to do. To be useful. A table might work better. So organize your information in a table showing the total number of rabbits for the first several months, at least 6 months. What patterns can you find in the table? Describe the pattern of growth in words. And then, so here's what you're going to do. I'm going to stop here. You are going to finish this problem for homework. You're going to make a table of the number of rabbits. Then you're going to, for 6 months, try to find a pattern. Then letter C, if you have not done so already, use your pattern to determine the number of rabbits that Lenny and George would have after 1 year has passed. And then how does the growth in the table that you created compare to the growth patterns that you have investigated previously? How is it similar and how is it different? So you're going to create a table for at least the first 6 months. We have the first 4 months right here, right? We know the first 4 months. You should be able to get some data from there and maybe find a pattern. I want you to try to analyze that pattern. I'd love for you to actually make a prediction of how many bunnies you think they're going to have after 1 year. It's pretty crazy. Well, if you want to, go for it. What do you think they'd have? And then you're actually going to find it. So tomorrow when you come to class, I want you to have this table filled out with the first 6. Actually, you know what? I really wanted to go all the way to 12 months. So basically, you're going to make a table all the way to 12 months and figure out what happens, okay? And then try to find a pattern in the table. That is your homework. Finish the diagram, make a table, and see what you got. By the way, when you come to class tomorrow, remind me and I'll show you the diagram a student drew last year, which is pretty intense, but pretty accurate. To actually show 12 months of growth like this is really, really, really tough. To create it in a way that actually can be shared with someone else and they can understand, it's quite challenging. But hopefully, we'll see what pattern you come up with. I want to see your pattern tomorrow. And then the first 12 months. Okay, how many bunnies would be after 12 months? Got it? Have a great day, and we'll see you. And that's all your homework. You don't have any review, preview. Oh, I forgot to put the, hold on. I forgot to put my comic. There we go. So you can pause it and read the comic if you want to, or you can just move on from there. Cool. I will see you tomorrow. Have a great day.